Okay, so good afternoon. So welcome back. So we are in lecture number 3. I hope the video's quality is much better today. Can anybody say, do a thumbs up or something on your?
It's very clear, sir.
Okay, very good. That's the difference. It can. Very good. Okay, so my trip to Chennai is not wasted. All right. So let's get going with this. So today we are going to introduce Python. My student, thank you, Soumya. So research scholar Pratik Suresh, who is working on heat transfer. He's into his 3rd year of his PhD. He'll help us. He'll take us through. So I will start with an example, which I will show in Excel, and then he will tell you how to do it in Python. Okay. All right. Ready? Okay. So just for the sake of continuity, so let us try to revisit the last slide of the previous class. So data cube aggregation is a way of compressing data and storing. There are several ways of compressing data. Okay, so this aggregation, what I'm showing you now is one example. Let us consider the length, breadth, and height of a cube, and assume that you've got millions of cubes or something, 3 dimensions. It could be height, weight, BMI, blood pressure, sugar level, cholesterol of people, or whatever. So now you want to, in this case, it's length, breadth, and height of a cuboid. So x is 62 centimeters, y equal to 25 centimeters, z equal to 33 centimeters, for example. So x is equal to 62 is now you put in binary in this form. Y equal to 25 is in orange, and z equal to 33 is in blue. So this is what I was working in the afternoon. It takes a lot of time for us to do one lecture if you have to do it properly. Right now, if you put x, y, z all together, x representing the leftmost 6 bits representing x and the rightmost 6 bits representing z or z, then you can get all the 18 bits. And so a binary representation like this, for a man on the street, you wouldn't know. You'll just think that, or a child will think it's a combination of zeros and ones. Only we will know, because we are the fellows who created it. We know that it is actually represents the 3 features, 3 dimensions of a cube, and then it has to be done 6 bits, and then those 6 bits have to be converted. When you convert, what you get is in centimeters. So all the rules you're applying. So when you apply all these rules, you can get many things. You can find out, and you can do mathematical operations on this. You can get what is the surface area of the cuboid, what is the volume of the cuboid, which is the longest dimension, whatever stuff you want to do, you can just play with the data. All right. So the above is a simple binary representation of all the 3 dimensions of a cuboid. Like that, there are, suppose you're working with a lot of variables, there are some things called as principal component analysis. So what it means is, instead of all the information, something is a function of x1 to blah 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 xn, you store it as features. Okay. You just say if it is one feature, 1 represents 70%. Okay. 2 features represents 90%. Represent 3 features represent 99%. If 99% of all the features in the original data is explained by 3 of this, okay, by 3 components. What happened, Giri? By 3 components, then you can say that 3 components are enough to characterize the data, and you can reconstruct, and from these 3 components you can get back your x1, x2, x3, whatever. So this is basically principal component orthogonal decomposition, principal logarithm, POD, PCA. Many techniques are available. What I've shown is basically a simple representation of 3 dimensions or dimensions of a geometric object using binary representation. Okay. Data discretization, dividing or binning into manageable parts. First, take a big database. And divide it into, for example, male and female. Then age. Okay. Then nationality. Then states. Whatever. So you can keep on binning the data. For example, if you're dealing with temperature data. So It's a large data containing hundreds of thousands of points. Then now you split the data into cold, moderate, and hot. So you have to qualify that. Cold means the dry bulb temperature is less than, let's say, 10 degrees or 15 degrees, 20 degrees. Okay. Moderate is between 20 and 35 or something. Then hot is greater than 35. You have to see whether it is a mean or the temperature at 2 p.m. or something. Once you tell the rule, then you can classify the data set into 3. Then you can find out how many days, number of points in your data set is cold, moderate, and hot. If you want to do a statistical analysis over time, over a period of 30 years or 40 years, how many cold have become moderate and how many moderate have become hot or vice versa and all that, and try to extract some physics or insights from that. Okay, that will be further data analysis. Okay. An example, now let's consider an example for health and social sciences. This was ready to avail, it was easily available. So given the short time, it was not possible for us to get a big data set in atmospheric science. We're working on it. In subsequent classes, we'll take some radar data and all that also. I've asked one of your colleagues to give us data about this water quality. Somebody's working with Professor Srinivasan, water quality, uranium content and all that. We'll just look at the data and see whether we can present in one of the later classes. Okay, now the following is a data set that involves child mortality rates. Okay, and it is based on data from UNICEF. This original data set is freely downloadable for all of you. You can download it from the internet and start and look at it, and you can play with it. Okay, the data set has a number of missing instances which need to be fixed before a clear progress on the reduction in child mortality rate can be explained from the year of 1990 until now. Okay, this is a busy line. So let's dissect it. It has a number of missing instances. So there are some missing data. So we'll have to use our data filling or data cleaning techniques. The simplest would be to delete rows, but a good data scientist will not keep on deleting rows, because if something has only 2 features and one feature is missing, if you delete it, then there'll be only one feature, with which it is highly risky to propose an hypothesis or do analysis and analytics and so on. Okay, so there are a number of missing instances which need to be fixed. Then what is a funda? The funda is basically to study it with a view to seeing whether has there been a reduction in child mortality rate. Suppose this is some average data all over the world. Can you split it continent-wise and country-wise? Then if there is a sudden dip, are there some medical interventions which are taken place? What can you say about this child mortality rate in the year 2030, 2035, 2055, 2075, and so on, so that you can ask governments, because it's a UN body, you can ask governments to take make concerted efforts to reduce the child mortality rate. All right. Okay. This problem now means that the problem is using this data set. I'll give you the data set. Using this data set, of course, this lecture will be available both on video as well as the PDF will be available to you. Okay. Just listen to the lecture. Use this data set to complete the following tasks. Address all the missing values using the techniques at your disposal. Prepare the data set to establish the following relations. Under 5 mortality, not rate and neonatality rates, infant mortality rate and neonatal mortality rates, and year and infant mortality rates. Okay. So there are 3 mortality rates, that is neonatal, infant, and under 5. And then there is a 4th dimension. It is all these data are given against various years starting from 1990. Okay, so this is the data set. Let's look at the data set. Okay, now 1990 to 2016, you can see the data is, because it was not possible for us to accommodate it in one slide. I didn't want this to continue to 2 slides. We have packed it in this slide itself. Okay, the data is basically death rows, columns 2, 3, 4. And subsequently, in the second half of the slide, columns 2, 3, 4 give you the death per 1,000 live births. Okay, the data is only up to 2016. Now you can see, let us look at mortality rate. Under 5 means within the first 5 years. So that is 93.4. Infant, I'll tell you, I'll qualify this. So that is lesser than the under 5. Neonatal is lesser than the infant. Now, look at the data slide. Look at the data carefully. The first thing you can see that all the 3 death rates seem to be continuously decreasing with time. Obviously, this should be the case. Our children are becoming healthier and we're able to conquer more diseases. Technology is improving and many people are having better access to healthcare and better access to clean water, air, I don't know, access to clean water and so on. Okay, Now let us look at column number 2, 93.4, blah, 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 all that. 97, the first data is missing. Under 5 mortality rate. Is everybody with me? Are you able to, can somebody say yes? I'm not able to see you. Did you spot the first missing data?
Yes.
Very good. Okay. Now go to 1994, the neonatal death rate is missing. Okay. And then in 2002, the infant death rate is missing. Okay. This basic, okay. All these data are available. No, we are just trying to work out this example. So deliberately we removed some data. All right. This is how we set up the problem so that we can understand. And later on, when you're confronted with an actual data set which has got missing values, you'll know how to fix them and then proceed further. Likewise, you also have data missing in 2005, 2010, 2004, and so on. Okay, so this is the problem posed to you. What is the problem posed to you? Okay, this is the data set. Some data are missing. Use whatever techniques, what have you stuff. Use whatever techniques are available at your disposal to first fill the data, clean up the data, and make the table clean. Once you, the easiest for you would be to remove 94, 97, wherever any data is missing, then you would have reduced 7 or 8 of this data, because of the absence of one entry, if you're removing all the other entries, it is not smart work. It is simply, it is just basically you're lazy and you don't want to spend more time on this. You don't want to, you means what? The analyst, he doesn't want to spend more time on this. Why unnecessarily? When you're cutting one row itself, full row, for the sake of one data, you're losing the other 2 data. Don't think so. So it will make it simple. You can have data science is not to make it simple. Okay, data with all the data available, try to make the best use of the data. The problem posed to us now is first fill it up, plot it, look at the trends, comment on the trends. Is there some relationship? With this relationship, can you get down to a little more statistics and do something with this? So this is the problem which is posed to us. Now let's flesh out the terminology. There are 3 death rates. Under 5 mortality rate. It is a death of a child which occurs within the first 5 years of age. Under 5 mortality rate. Neonatal mortality rate. The death of the child occurs within the first 28 days of life. Within the first month. Okay, lunar month. Okay, within the first 4 weeks, if the child dies, unfortunately, then it is counted as a neonatal mortality. Infant mortality is death of the child occurs within 1 year of life. So I'll come again. Under 5 mortality is within 5 years. Neonatal mortality is within the first 28 days. Infant mortality is within the first 1 year of life. So it stands to reason that the under 5 mortality rate is the superset. It's going to give the highest value, followed by the infant mortality rate, followed by the neonatal mortality rate. Because one is the infant mortality rate is a subset of the neonatal. The neonatal itself is a subset of the under 5 mortality rate. Okay, now don't do any complicated maths. No, don't do statistics probability. First, visualize the data. Plot it. X-axis is 1990 year to 2016. Y-axis is mortality. Then take 3 different colors and plot. The lowest is the neonatal, which is in gray color, gray scale. The next one is in orange color, which is the infant. And the top is the under 5. Now you can see that continuously is decreasing, but there seems to be a change of slope. That's what I am able to observe. There seems to be a change of slope somewhere, starting from the year 99 or 2000 and so on. So some medical intervention has taken place or something, but or we don't know, the polio was eradicated, whatever. So we have to cross correlate with whatever other events have taken place. But this is absolute raw data. This is called raw data. Okay. Now this is given to us. Now let us get into the problem. Now, for example, the 1997 under 5 mortality rate was missing. So now what I can do is I can put a yellow, I can highlight it with yellow. Okay. And then take the average of one data point above it and one data point below it. I'll come again. 1997 is missing. So 85.6 plus 82.1 divided by 2, 83.9, which is entered as red. That is a filled out. That means we have done data cleanup. Okay, so I have entered now 83.9. In a similar fashion, I have done for the neonatal for 1994. We have done it for other things. So you can see that all these yellow patches will have at least 3 columns, and whatever has been filled out is the average, which is given in red. Now the table is clean. There is no missing value. Okay. Up to this, it's clear. Is it clear?
Yes, sir.
Very good. Okay. So far, so good. Now we turn around and plot it. Ha! Now it is very nice. Now, this one looks very clean because now all the data are entered, even the missing data, we have done something. We have actually done some data science with this. Okay. So we have just used some averaging, local averaging, and you can see there's something called R square. R square is basically the sum of the residuals. I'll later on explain in a heavy statistical class about this. But let me explain it today. Okay, let us say the height of a person. We already took this example. Okay, height of a person. What is the counter? Okay, let us say, or the count, whatever. What do you call it? Number. Whatever. So you just say 1, 2, 3, 4, 5. Okay, let's say that. All right, so this is the entry 1, 2, 3, 4, 5. Now, I think the mean will be somewhere like this. Okay, so let's say that. So this is the y bar. So y is the height. If you didn't know anything further, what you will say is there is a mean. Okay, there is also a sigma square. I think I divided by 5 itself. So we need to do n minus 1 and all that. Girish, should we do n minus 1 or we'll stay with n? Pratik? Huh?
Small data set, sir, for small data set, we used to do n minus 1, right, sir?
We used to do n minus 1. Okay. That's what I taught you.
Sir,
you took so many courses. All right. Okay. Let's say 4. Because one see that it basically this bottom is the degrees of freedom, but it's not a private conversation. Don't get other people don't get put off. Since we already used one of these things to get the mean, so it should be n minus 1. I think I'm fine with this because statisticians never seem to converge on this. So we will now say that the best way to represent the data would be average height, and then there will be the sigma square is called the variance. Okay, total sum of the deviations of the heights, total sum of the squares of the deviations of the individual height with respect to the mean divided by the number of observations minus 1. Now, sigma is the standard deviation. So one possibility is to say that, can you tell me the height of the, suppose somebody asks you a question, randomly I pick up a guy. Can you tell me his or her height? You are saying you're a data scientist. Oh, I see. So if you want me to do that, then I will say y bar plus or minus 3 sigma. So I will say that 99% of the time, any fellow's height will be this. Yeah, if you have a normal distribution, if you have more number of data points, there's something called the central limit theorem. So this will work. Okay. Now, let us cook with fire. What do you mean by cook with fire? Now, let us say, so now it could be anywhere. This could be 3, 2, 4. These are the characters, 5 characters, huh? 5 guys, 5 girls, whatever, what have you. But this should be, if you combine girls and boys, this will not be a proper correlation. Let's say, for argument's sake, all are girls. Okay. Now, if I say, now I'm able to draw some straight line. So there seems to be some correlation. So if you tell me the age, intuitively I can guess that with increasing age, the height is expected to be more. Now, if we say that y equal to ax plus b, where y is the height, all right, and x is the age, I have to find AB. So that is basically regression, which is coming in the next class or maybe on 22nd. Okay. Let's say assume you are getting A and B using some procedure. What will be that? So I can do what is called a desi way of doing it. Okay. A desi way of doing it would be, I'm searching for the cover of this pen. I got it. A desi way of doing it would be, let's say for today's class, for starters, let us say that we want to do what is called a visual best fit. So you just take a scale and then you will do all these lines. You will find out whichever line, wherever this deviation and this deviation points are equally spread about the straight line, and that gives you the minimum total error. It is a compromise. Okay. You want to go to this restaurant, your friend wants to go to some other restaurant. You don't like Italian. She doesn't like 3 people. One person doesn't like continental. One person doesn't like Chinese. One person is North Indian. There is one person who is boring like me, who likes only idli, vada, dosa. How do you compromise on? You'll go to some above average multi-cuisine restaurant which will serve all. Okay. Otherwise, it will not be. Otherwise, all the janta will not be satisfied. Okay. So eventually life is a compromise, right? Whatever you're doing. So let's say that, so you arrived at a compromise, you got ax plus b. Now you do yi minus ax minus b whole square. Okay. Sigma I equal to 1 to n. That means, tell me the age. I've already found out a and b. I can get a height. Now this will be subtracted from the actual height y data. So let's say this is y data. Y height, okay. Y height. Okay. And now let's say this is the SR. So some residual. Now the ST was, original residual was I equal to 1 to n yi minus y bar whole square. Now this game of correlation is good if now there was original deviation S. Now using the correlation, you reduced it, divided with the original residual ST. ST is base, T is means total. S means regression. So you can also write it as 1 minus SR. Therefore, by proposing a hypothesis that instead of just looking at the data blindly as 1, 2, 3, 4, 5, if you assign an attribute or a feature, we call it as a variable. Data scientists will call it as an attribute or a feature. If you attribute a feature called age, once that age is defined by X, and then you're able to do some calculations using a regression and statistical principles, you're able to get a fit such that whenever you put in the age, you'll be able to get the height. Now you're able to get, now you're seeing that the total sum of the residuals upon doing the regression is SR, whereas before doing the regression, only with mean, you're getting, yeah, I'm getting a call. Only when you take class, there is also from respected spam. Sir, are you interested in credit card? Okay, let's get back to the get back to the lesson. So this is what This is plain and simple. There is no regression with the just original data with respect to the mean what you get. This is after the regression, this is the total. So this tells you how much the regression as how much, what is the fraction of the residuals or what is the fraction of the variability in the data, which is reduced by the application of, a correlation or a regression. Therefore, this is called R square, where R square is called the coefficient of determination. This R is called your whatever Pearson's correlation coefficient, whatever correlation coefficient. Maybe the Pearson is having a minus also. The way I have defined it, you should have only a positive correlation coefficient. So if the correlation coefficient is close to 1, that means this SR is substantially lower compared to ST. Therefore, R square approaches 1. If R square is exactly 1, you've done some cheating because SR can never be made 0. Because whenever, either when you do calculations or when you do some measurements, it's always the case that you'll have some error. Okay. So this is this R square. So what are the simple R square? It was so innocuous. But please note that it is not just innocuous. It is deceptively innocuous. And there is much to it. There's much to it. It requires an explanation like this. Now, let's look at the X versus under 5. Correlation R square is 0.99. R will be root of 0.99. It will be 0.9939. So the infant mortality rate 0.993, neonatal is whatever. Now we are doing, if you tell me the under 5 mortality rate, I'll tell you the neonatal rate. So that is an additional feature which you're able to see within the underlying correlation in the existing data rather than just looking at the time series of the data. Please note that the top half of the slide shows a correlation with respect to the year. Okay. What did we do? Year minus 1989, so that the first data point becomes 1, the second becomes 2, and so on. So the year has been converted into a running variable with 1, 2, 3, 4, blah, 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 up to 2016, which is 27. The last variable is 27. So with respect to that, you are getting that correlation. So it gives a linear fit, which is okay. And it is minus y equal to minus 2.2176. So minus is very healthy because it tells you that the mortality rate is going down with time, which is very good. The 2.27 gives you the dy by dx, whatever. It gives you the rate at which it is falling. So that we'll have to see. We can do some micro, blah, 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 whatever. So you can look at this correlation from 90 to 95, 96 to 2000, 2001 to 2006, whatever, and you can subdivide the data and see over a 5-year or you can see the decadal variation. You can see the decadal variation or every 5-year variation in this, and you can play with it. The full data set is available. Pratik will tell you where it is available, and you will move on to Python after I am done with this. Now let's go to the last two, what is that plot? So now you can see that x-axis under 5 mortality, y-axis the neonatal mortality. So that also seems to have a linear regression. Now the infant mortality versus neonatal, that is the last southeast corner of the view graph of the slide, which also shows a very high correlation coefficient. Please note that in spite of we doing the data filling, the correlation coefficient is very high, remains at 0.99. So if something is presented to you, you will not even know that we've already done some data cleaning and data filling. Is that clear? So we are doing a regression on a cleaned up database, and it seems to be working well. Did you all get that idea of this? Now you can apply to your glacier data set, this thing, water quality, aerosol, whatever. So this is the first step. Clean up, put it in ascending or descending order, identify the variables. Please establish causality, like with increasing height, with increasing age, height will increase. So if you're establishing a causality, then start playing with the data and do your correlation or regression. Is it clear up to this stage?
Yes, sir.
All right, let's move forward. Now, sir, I don't like what you have done. Very good. You don't have to like whatever I have done. I have a different way. Please tell what it is. Yes, sir. I want to do something different. Yes, please tell what it is. I want to take the mean of all the under 5 mortality rate, and then that mean I will put it as the missing. Very good. Good proposal. Go ahead. So if you do that, for 1997, the mean of the whole sample of that column is 68.67. You put the mean as 68.6. Fill it out, red one. Similarly, fill out the infant mortality rate for 2002. Fill out the neonatal for 94, under 5 for 2000, what have you stuff. Then, now you fill it up. Now, whatever fundas we have used, now apply the same fundas and try to get the regression. Let's do this now. Now you can see that the regression has gone down, and also, Array. Pratik, I should be able to draw this, no? No. Okay. I don't know why it's not allowing me. Okay. Now you can see that the R square has gone down. Also, your filling out strategy of using the global mean turns out that it produces the outliers. The outliers in the graph or whatever you have proposed in all the graphs. Okay. X versus under 5, X versus infant, X versus neonatal. So your strategy of using the global mean to fill out the missing data is not working. It's not working. Local mean seems to be working. Sir, why is it, sir? I'm using more data points, more the merrier. You only said that data science means all the data have to be used, but it is a constantly decreasing death rate. In that, if you use a global minimum and you use it as a substitute for a value which is high up in the data in the table, which means if you are using it as a substitute for 1994, 95, when the death rate is very high, the global mean is very low, it will definitely be an outlier. And now, as the time period progresses, because of advancements in medical science and healthcare, when the infant mortality rate is coming down rapidly, if you are using again a global mean to fill out for a value which is coming late, like 2010 or 2011, it will show a value which is higher than what the trend seems to suggest. So these are representative and as clearly represented as something. The first outlier is under predicting the infant mortality rate. The second outlier is over predicting the infant mortality rate because this average is not able to keep up with the rapid variation in the infant mortality rate as evidenced by the data which is presented to us. All right. Now, same way you can see that if you do the correlation also, you get a messy correlation of under 5 versus neonatal. Go to the bottom. Infant versus neonatal, R square is coming down. Therefore, don't think the global mean is simple and okay, not working. Instead of taking average of 2, you can take the average of 5, whatever. But if you try to include as many data as possible in a data which is very sensitive like this in a database, your global mean just simply doesn't work out. Now, they see cleanup. Sir, I don't want all this, sir. I will delete the rows. Please go ahead. So already the data has shrunk. You already lost many data. It's okay, sir. I have a lot of data. I'll work with this. Okay. If you do this, what happens? So we just knocked off all those rows, even in which even one entry was missing. Okay. R square is reasonable, but there are some missing data points. Okay. This is not bad. This is not very badly off. But if you're having sparse data, there's no point in not doing data filling and continuously eliminating the data. So in this simple example, okay, this simple example, because we took only a little bit of the data set. In this example, so we just saw how to do data cleaning, how to look at the plot, how to see causality, what is regression, what is a mathematics, what is a mathematical expression for regression, coefficient of determination, and also the correlation coefficient, how we can do data filling in three ways. One is data chopping, okay, deleting the rows. One is global mean, one is this thing. The other can also be, there could be other ways. So data science basically is not fully science. There can also be in art. You can also come out with your own ways of filling out. So now we have seen this example. Now, I will go through this next 2-3 slides and then hand it over to Pratik. All right. Now you can do, this is Likert. This is Professor Rensis Likert, American psychologist. So you can do further work on this. What is this? A Likert scale is a psychometric scale commonly involved in research that employs questionnaires. In this questionnaire, this scale is the most widely used approach to scale responses. You have seen a typical 5-level Likert item. No? For example, some question is asked, strongly disagree, but actually the strongly disagree should be 0. Unfortunately, it starts usually with 2. 2 out of 10 marks means strongly disagree. Disagree is 4 out of 10. Neutral is 6 out of 10. Agree is 8 out of 10. Strongly agree with 10 out of 10. Okay, so this is a 5-point scale. So somebody will be saying, what are you saying, sir? You just already presented. Why are you bringing something which is unconnected? Oh, no, it is not unconnected. It is very much connected. Now this data set of mortality rate, you present it to a group of social workers, present it to a group of mothers, present it to a group of pediatricians, okay, present it to a group of public health experts. Now you ask them, tell a hypothesis. The world requires much more more funding needs to be required, international cooperation is required in the medical field to reduce neonatality rate. So if the sample is 1,000 people, you can do an online poll, whatever, or a survey, strongly disagree, neutral, like that if you do, and several people are collecting, now you can do a statistics of that and say this is agreed, this is agreed. So I have done a poll, and then based on this data, we have found that 80% of the respondents are saying that the world is not spending enough on this. Therefore, there should be a movement to spend more money on this and invest more in medical research and so on. This is how, from data science, you can go to psychology, you can go to whatever, and then you can do, so you can convert it to a scale and so on. So this is how it is done in marketing and this thing also. So the moment you fly in Indigo, whatever, yesterday I came, immediately they say, what is your rating? Are you satisfied? The default, it keeps 10 out of 10. Okay, so, and then you have to just put somewhere, if you click, it will say, thank you for your response, even before you give a response. All right. Okay. Now, okay. Suppose I want to, as they say now, the buzzword is deep dive. I want to deep dive into this problem. Okay, I want to dive deep into the problem of malapropism. In order to dive deep into the problem of child mortality, this data can be looked at by a target group, say a group of social scientists, public health experts, pediatricians, and this group could be asked to rate the progress we have made continent-wise, country-wise in the last few decades in reducing the infant mortality rate as perceived by stakeholders in society, as perceived by these stakeholders. This may spur discussions with a view to framing policies for creating a better world with minimal child mortality rates, which is a very, very noble objective. All right. Now, the original data set is available at https data.unicef.org.topic child survival under 5 mortality. Okay. So this is for those people who are motivated to work on this problem further. Don't worry that I'm not presenting an example in atmospheric science. This is just example is only an excuse. Once you learn the technique, you can apply it to any data set. Now, should we hand over to? I'll stop sharing. Prateek.
Yeah.
Prateek, Suresh. All right.
Yes,
how many people are there today? 39. Okay. All right. Yeah, Prateek will do this example on Python. So it'll take about 15 minutes. All right. Okay. Go ahead, Prateek.
Sure, sir. Hey, may I know how many of you are new to Python? Completely new to Python. Hello, can you hear me?
Yeah, can somebody respond?
Yes, we can hear you.
Yeah, he was asking a question. Python. Are
How
you
many
familiar?
of you are new to Python? May I get a count of? So it seems like, yeah, okay.
I think it's many people are new. Python is basically for ML, data science, right?
Yeah, okay.
Yeah, either nobody, mostly they don't use. Okay, go ahead, Prateek. Okay.
Yeah, sure. So, sir, we'll start with the introduction, sir.
Yeah, go ahead.
Okay.
So full screen, huh?
Yes.
So you can pin Pratik's video, right? If you have a Pratik screen. Are you sharing now, Pratik?
Yes. One sec, sir. I didn't share you. I forgot to share, sir. Yes, sir. Now.
Yeah, go ahead.
Okay, I'm in the full screen. Okay. So those who are starting with Python, these two commands are very helpful for you. Like you can use dir command if you want to know what all methods particular function supports. I'll show you. I use Google Colab to do my machine learning projects. So Google Colab is a product from Google Research, which lets you write and execute Python codes in the browser itself. So you don't need any other installations, and it is well suited for machine learning applications. So if you are familiar with Jupyter notebooks, Google Colab is no different from that. So let's open one Google Colab sheet. So this is how I open. So I'll click new notebook and let's wait for it. Yeah, so this is the interface I'm having. I'll zoom it so that. So is it visible now?
Yes.
Okay, the first, I was talking about the dir command. So let's say dir, if I want to know what is how many functions this list supports, something like that. So if I do like this and if I execute, it takes a while to connect. You can see connecting. So it is connecting the server. This is just a first time. Yeah, it's get connected. Yeah. So just see the functions. These are the methods that list supports. So like append, clear, copy, etc. So if you want to know what each function is, let's use help command. Help, and you can type like this. So this is a list, and we are putting a dot just to inform, like, this append is a method which is listed under list. I mean, which is defined under list. So you'll get like this. So this function basically appends an object to the end of the list. So similarly, you can go through all the functions and try out learning yourselves. So this is a first way so that you can explore Python. Now we'll go to the next slide. So everything in Python is an object. Again, we'll have mutable as well as immutable objects. So I'll show you what is an immutable thing. Let's say if I creating a code, and let's say if I define a equal to 4 and id and trying to print the id is the kind of memory location. It doesn't print. Okay, I forgot to pass on the variable, that's why. Yeah, now it should go. Yeah, see, one memory address got printed. So now let me change the a. Let's say a equal to a plus 1. Then I'm trying to print the same id. Let's put after so that we'll get to know that. See, the memory address changed, which means if I change the value of this a, since it has been immutable, it changes the memory locations. So similarly, this happens with string and tuple also. But list is a mutable object. So it's like, when you create a list, in the similar way. List is created like this. You can have 1, 2, 3. So this is like basically like an array in C++, but more powerful than an array, because this list has, even the list can contain one more list. So that does that. This complexity is not allowed in C++. So this, I can define the list like this also. So again, if I do print ID of B, it shows a memory address. And if I am trying to, let's now already we have seen append function. So let me append one more object. So it's 5, and I'm trying to print the memory address. Okay, sounds good. Okay. See, the memory address didn't change. So this was intentional from the developers of Python, because the list is so complex that if you want to create, if you made a small change, and if I'm using a different memory location, then the internally it has to copy all the contents from B to a new location. So instead of that, it kept the same memory locations. So this is again you have to be very careful of this function when I'm using C equal to B, and when I'm trying to print the ID of C also. But this is what differs from C, C++, where it creates different memory allocations. See, the memory address is again same, which means if I append something to C also, let me append 5 to C, no, let me append 6 to C, and I'm trying to print B, because B we haven't appended 6. And if you try to print B, oh, what happened? Oh, this one. Okay. See, the 6 is appended with B also. So which means C and B are sharing the common memory address. So this we have to be very careful when dealing with Python. So list is an immutable object. So it shares memory location. So whenever you have something like assignment, it carries the same memory address. So you have to use some other functions like you can use deep copy and all to have a separate memory locations. Otherwise, you can use list slicing, something like this. You can have slicing like this, and you can do, we'll have a different memory locations. So I'll go back to the presentation. Now these are Python strings. In C++ or C, we have only double quotes to print out something like this thing. I'm sorry, but in Python we have single quotes, double quotes, as well as triple quotes. So without an escape sequence, you can manage printing a statement like this. So basically, I just want to introduce that Python supports single quotes, double quotes, and triple quotes, apart from double quotes in C++. So this is string formatting basically in Python. This is C-like, and the second one is Python. And in Python, we can have multiple initialization at one go, which is very handy. Like in C++, we can have only like A equal to 1, but in Python we can have A, B, C equal to 1, 2, 3, something like that. And if I print C, it will show. It will show 3. Yeah. So multiple initialization is there. Then in swapping, for swapping in other languages, we need a third variable. Again, we can do it, otherwise also, but usually we'll use a third variable like temp, and we'll use to swap. In Python, we can do simply like B, A equal A, B. So that is very simple. And for chain comparison, in other languages, we'll have x greater than 3 and x less than 5, something like that. In Pythonic, we can just write the mathematical expression like this. Similarly, for truth value checking, like if the list is, let's say item is a list, and if you want to check whether the item is, it is not, the list is empty, then we can simply do if item, that's enough. rather than doing like if length of the item not equal to 0, which is which is followed in C++ and C. And this is the for loop which typically used in Python, rather than the I and I less than 10 plus plus I, which we use in C++. So basically, I'll show you a for loop statement. So let's say I have a list like 1, 2, 3, 4, 1, 2, 3, 4, and the for loop works like this: for item is a variable, like we can use anything. Item in A is a list, so we need something to iterate. That is how the for loop works. And I should put a double colon, telling the interpreter that I have some more statement coming up. Then I will use print in brackets A. Okay, what happened? Oh, I printed A. Ideally, I should print item. So the first thing you noticed is, I haven't specified any new line character, but still Python puts a new line character. So that's a default thing in Python. It puts a new line character by default, and it takes each value from A, and it prints like this. So this is a basic for loop structure, and you can again use enumerate also with this in enumerate. This enumerate function throws the index also of A. So like this. So since it throws index also, I need some more variable to collect that index. So let's say it's index and index comma, and I'll put some. Okay, it should work. See, it is printing the index as well as the data. So this is the other way of using for loop. So this is a way to go in Python, not like I equal to 0, I less than 10, and plus plus I, all those things. Now, so this is list comprehensions. Now you can read more about that. Now basically it's like you have a multiple statements like this, which you'll do in other languages like C, but you can basically compress it in a one line code, which is awesome. So with this, I think we can go into the code, and I will show you. Now I'll explain the basics there as well. So can I move on?
Yeah, please go on. Please go ahead. Go to the problem.
So this is a mortality rate problem.
Now this mortality rate problem is being solved by Python, because basically some students came to me last week and said, sir, we want some hands-on. So I asked Pratik 10 minutes, a very short introduction to Python. Now he'll tell you how to do this thing. And this code also we can give it to them, no, Pratik?
Yes, sir. Sure. Why not?
Yeah, by email you can give it to them, so you can play with this code and all that. All right, please go ahead.
Okay, first we need the data set. So this I'm using Untitled mortality rate.
This is the original data set, the source. So he's connected on the internet. Connected
We'll
to
have a
the
Google search and
okay.
See, we have the data over here. It's a download spreadsheet. So I have already downloaded that, and the data looks like this. It's
so it's country wise.
Yeah, country wise, region.
And then median, lower, and upper. You can just tell them. It has got three entries.
So what I have taken for this particular example is I've chosen region as a world, and I'm used median as the the data. So I've copied all this data from 1990. Basically I converted 1991.5 to 1991 for now easiness. Then till 2021, that is the data that we are having. You can see 2020.5, so it's 2021. And I've created a CSV file like this.
CSV is comma separated variable. Please note that I introduced this in the previous class.
So basically it's again a spreadsheet like file, and have copied the year and the corresponding neonatal mortality rate. So this is our data set. Now we have to load this. This is in my PC, not in the drive. So I have to collect this data to my Colab. So I can use this particular code to fetch it from my PC. So it will ask for choose a file. So then I can go back and select the CSV file, open. Then it will show the completion, or it's 100% done. Now we have to have something. Now we have the file in my collab notebook. You can see here also, like in the folder. See this neonatal is there. Then now I need something like some module to work with this data. So pandas is that kind of a module. It's a Python library for working with data sets. There are functions, and there are inbuilt functions for analyzing, cleaning, exploring, and manipulating data. So you'll see as we go through these exercise. And so let me execute this call, the cell. See our the data has been taken by the pandas, and it has added one more row and one more
Excuse
column.
me?
Hello.
Pratik,
Yeah.
can you explain again like importing the data in the Google Colab?
Yeah, yeah. Oh.
Okay. No, this is basically just a code provided by the Google itself. All we have to do is just click. This is a module that it is taking from Google Colab, and it is importing one method. And I'm trying to use the same thing. So it is basically a plug and play code. It's nothing, no more to it. You can just execute and it will show. I'll show you one more time. It will show a choose file option, and I can choose.
So it's just like a drop down, pick up file, pick up your
Yes.
PPT from.
Yes, sir. It's directly provided from the Google itself. So it will show like this. So once a file is loaded only, then I can work with the file. That is what. So otherwise, I should put this file into some drive, and I should take I should access the file from the drive, something like that. So instead of that, I used my local PC itself. So once that is done, we can use pandas to import the data.
Now it creates one more row, one more column, 0, 1, 2, 3.
Yeah, that was I was trying to say. So it automatically created one more column. This is just a kind of a primary key when you are if you are familiar with SQL. So it adds one more unique number, so that I can uniquely identify each rows. In this case, it is not that needed because our year is itself as a unique key. I could have dropped this particular column, but I didn't do that. Just to be in the simple side.
So it helps us to correlate if you have that column.
It helps us to it's like a primary key, sir. It's a unique column.
Hey, Preetham has a question to you.
Yeah, yes, sir. I can't see the chat box.
Yeah, I can see that. Are Google Colab and Jupyter Notebook different functionally?
It is functionally same. The interface is also very same. But Jupyter Colab, it will be in your local PC. This will be in the drive. So I prefer this thing more than Colab for small projects.
But that also works, right?
Yeah, definitely, sir. If you are working with large data, and then it's preferable to have in the local PC itself. Then Jupyter Notebook, it's a way to go.
Yeah,
but
I
if you
think
have
Pratik, 5 minutes, huh?
Sure, sir. We'll go. So now the next thing is to get insights about this data. So we can use. So as we have seen here, we have used DF. This is a data frame. So this is a head that I have, so that I can connect to my data. So if I use info, I'll get. Now this is the information that I have, and I have 31 entries in year, and as well as 31 entries neonatal mortality rate, which means I don't have any missing data. Again. df.describe will show me the mean and standard deviation, all those things. So this is I can mathematically.
This is the basic statistics of the data.
Yes, sir. Then I can go ahead and visualize the data using matplotlib. This is another library in Python where you can plot graphs, and you can customize graphs also. I didn't customize that much, but so by seeing the graph, I can I can get an insight like the curve. There is a strong negative correlation as well as the slope is changing. Again, we can use a correlation function to get what is that correlation. So I'll get like minus 0.99, which shows me like there is a this data is negatively correlated. Actually, this shows linear correlation, so don't confuse with quadratic data. Again, this is just to I just wanted one more column where it shows the reference year, and I will subtract 1991 from every row, every column. Like, each year I will subtract 1991 so that I will get a reference year. Just to shift the data to a smaller value. Then here is a code which I used to create the training set as well as the test set. Basically, the training set will be used to train our data, and after once the training is done, once the model is created, then I will use a test set to
Yeah. So now I have to explain a little bit. So what we are trying to do is we are pretending as though 17 to 21 data is not available. Class, please note. So we are training from 90 to 2016 using this correlation, and we are trying to see from the correlation whatever it is predicting 17, 18, 19, 20, 21 ka neonatal mortality rate, is it matching with the correlation? That is the exercise. Okay, so we are trying to forecast the neonatal rate. Suppose you had data only till 2016. We pretend that data is not available. He is using all this Python to set up the correlation, and then we will see whether the prediction is good or no good or whatever. Please go ahead.
So for splitting this data set, either I can use sklearn module, which is well developed and well documented module for data analysis, but here I used my own function just to so this will split my data from 1991 to 2015. You can see the test data now. I'll show you the train data as well. This is train data, I'm sorry. Now I'll show you the test data as well. So this is our test data. Okay. Test. Okay. So this is a test set from 2016 to 21. So our model doesn't know what this data is. Now I'm taking out the x and the y's so that I can give to my model. So x is the year alone, the reference year. So I'm dropping out all other columns.
Yeah,
Similarly,
there is a message from Girish. Sorry, whoever has not filled the Google form, please fill it. Okay, because some mails regarding where the lectures will be available and so on, like, okay, will be sent. Huh?
Okay. So in Y, I'll use.
Preetham is saying something. Preetham, I will answer your question later. Okay. Let Prateep finish it. Okay.
So once we have this X and Y's, now we can go ahead and train our model. So this is our X. Now I'm trying to select and train the model. So initially I tried with the, these X's and Y's. X's means a reference year and Y means a neonatal model, and the model performed worse just because we have a, our slopes are changing in the later part of the years. So we need to have some kind of transformation on Y, so that, and the numbers are very, very large also, like 36 and 40, something like that. So we have to shrink those numbers so that this linear transformation can be fitted properly. So I used a log transformation, and I need to, the inverse will be an exponential transformation. So what I did is I changed all the y's to log of each y's. Then I trained my model. Then while printing and while showing the output, I'll use an inverse function that is exponential. Then I'll come back. So that is what I'm doing here. And all these functions are defined in sklearn. You can go ahead and look into the documentation. So again, linear regression, we don't have to write any functions of our own. It's already written. And I'm trying to show you some predicted versus actual value. This is in the train set, not in the test set. So we are having some close values. And to put in perspective, the R square is 0.98. So this works good in train data. Let's see the plot as well. So this is a plot. Again, let's see how this.
This is the last part. No, the last part is how does it predict 17 to 21, 16?
Yes.
Okay.
Yes, sir. So all that we have done is we have trained our model, and we have.
So what does the model do? No training and all that jamela now. You give me the year, it will tell the neonatal mortality rate, correct, or whatever under 5.
Yes, sir.
Whatever.
Yes, sir. Yes, sir. Yeah.
Now we are checking whether it is good or not good. Okay.
So now I'm using this lr.predict. So this function will load our model, all those ax plus b, so that a and b it will learn, and it will use this predict function upon x to create that y. So see how close our model is, and it's almost good. See, our model was, we are trying to fit a straight line for a curve which is not so straight, and as you can see, the slopes were changing at the later part of year,
But still it
we
was
could-
quite good.
quite good. That is what that log transformation has done.
Hmm.
Again, you can do any other transformation.
You can do this with neural network also, but that will be towards the end of the course. Huh?
Yes, sir. Yes, sir. Maybe you can get a better prediction.
Yeah, we can get so we have to do artificial neural network and do that.
Yes. Yeah. Sir, any questions?
Yeah, you can close the presentation. So do you have any questions for Pratik? You can unshare.
Yes, sir. Yeah.
All right. Okay. I think we lost some few people. I think some people already knew Python or whatever. So I think we have gone a little slow today, but it's okay because some people wanted hands-on. That's why I gave 20 minutes to Pratik to take the same example and run it through Python. So there will be no more Python this thing. Sometimes we'll show it. The introduction to Python and all is only for today's class. All right. So we'll call it a day. So I have to complete some more things in this data, which I'll do in the next class, and start with the introduction to statistics. Following that will be regression, nonlinear regression, and we'll take some examples from rainfall, satellite data, and all that. And next class, I will also show you some ways of creative plotting, how to get insights based on creative plotting and so on. All right. So if you have any doubts in Python, you can ping, you can write to Pratik. Okay. So Pratik, you can give your email address now on the chat box.
Sure, sir. Sure, sir. Okay.
We could also look at the year-to-year budget allocation in healthcare. Yes. Preetham, very good. So you are from which department? Preetham? Hello, Preetham, are you there? Mic is not working. Okay. Hey, Pratik, are you typing now? Pratik, we lost you. Okay, I'll get this thing. Okay. All right. So, Pratik Suresh at smail.iitm.ac.in. Pratheek Suresh, no hyphen, no gap, nothing. At the rate of smail, student mail at iitmadras.academic.in. All right. So thank you very much. So we'll meet again next Tuesday. Thank you.